This tutorial is brought to you by PE Prep Engine. Free study guides and practice questions at peprepengine.com.
Week 2, Lesson 4, Minor Losses, Fittings, and Equivalent Length. We build on Lesson 3's Darcy-Weisbach setup and add the K factor that turns straight pipe friction into total system head loss. Real piping has two head loss sources. Major loss is wall friction along the straight pipe, the Darcy-Weisbach term from Lesson 3. Minor loss is everything else: valves, elbows, T's, entrances, exits, contractions, expansions. At each fitting, the flow separates and dissipates kinetic energy. Despite the name, minor losses are routinely the same order of magnitude as wall friction, and in a short fitting heavy run, they can dominate. The form to recognize: minor head loss equals K times the velocity head, V squared over 2G. K is a dimensionless resistance coefficient, tabulated per fitting type, size, and condition. For a whole flow path, add the K values in series and multiply by one velocity head. Minor losses scale with velocity squared, like the major loss, which is what lets us collect everything under one shared velocity head. 5 keyword patterns flag this problem type: gate, globe or check valve, 90-degree or long radius elbows, sudden expansion or contraction, entrance or discharge at a reservoir, or the phrase equivalent length L sub E. All collapse onto the same expression, FL over D plus the sum of K times one velocity head, provided diameter is constant, so velocity is constant by continuity. The working table: same pipe flow table from Lesson 3, with one new block bolted on. The fittings list, each row carrying its own K value, and a sum of K row. The velocity head row is shared. Every fitting and the straight pipe term multiplies that single number. For the K tables, the canonical reference is Crane Technical Paper 410. Memorize 5 K values. Look up the rest. Gate valve fully open, 0.15, essentially transparent. Globe valve, 6 to 10, much higher because the flow reverses twice inside the body. Standard 90-degree elbow, about 0.75. Sharp entrance from a reservoir, 0.5. Discharge into a reservoir, exactly 1. The entire velocity head is lost. For everything else, Crane Technical Paper 410. A second convention, the equivalent length method. Each fitting is expressed as a length of straight pipe that dissipates the same energy. Add those to the actual pipe length and apply Darcy-Weisbach once to the sum. The two methods relate by K equals F times L sub E over D. So this form depends on the friction factor. Pick one method per fitting and stay with it. The K factor form is more common on the PE, but if a problem hands you L sub E values, use them. An exam-style problem. Water through 120 feet of 4-inch pipe at 8 feet per second. Friction factor 0.022. 1 open gate valve and 2 90-degree elbows. Find the total head loss. Diameter is constant, so velocity is constant by continuity. One shared velocity head multiplies the entire bracketed sum. Step 1. The straight pipe contribution, F times L over D, lands on 7.92. It's dimensionless. Feet over feet cancels, which is your sanity check before multiplying by the velocity head. Step 2. Sum the K values along the flow path. 1 gate valve plus 2 elbows gives 1.65. That's already about 21% of the major loss bracket, so the minor losses are clearly not negligible. Forgetting a single elbow would drop the answer by almost a foot of head. Step 3. The shared velocity head, V squared over 2G, comes to 0.994. Handy estimator, at 8 feet per second in IP units, the velocity head is essentially 1 foot. Carry that for sanity checks. Combine inside the bracket, then multiply by the velocity head. Total head loss is about 9.5 feet, closest to choice C. The minor loss share is roughly 1.6 feet. Drop the fittings and you'd land near 7.9, flipping you to the wrong choice B. Combine inside the bracket first, then multiply by one shared velocity head. That's what protects you. 1 sanity check. Every term scales with V squared, and V equals Q over A, with A fixed. So total head loss scales with flow rate squared. Plot H sub L versus Q, and you get a parabola through the origin, the system resistance curve. Lesson 6 superimposes a pump curve on it to find the operating point. 5 errors that cost points. 1. Mixing K-factor and equivalent length methods on the same fitting. Pick one. 2. Forgetting the exit loss into a reservoir. K equals 1, a full velocity head, not 0. 3. Sudden expansion uses the upstream velocity head, with K equal to 1 minus the area ratio squared, not the downstream head. 4. If the diameter changes, each section needs its own velocity head. Don't share one across a step. 5. Unit drift. L and D must be in the same length unit before you compute L over D. In the exam room, this lesson becomes one term inside the extended energy equation in Lesson 5. Memorize 5 K values. Gate 0.15, globe 6 to 10, elbow 0.75, entrance 0.5, exit 1. 80% rule. Remember just H sub M equals K times the velocity head, and those 5 values, and you'll get most questions right. Onward to pump sizing.
The full study guide with every equation and common exam trap is free at peprepengine.com. Link in the description. Machine design, HVAC, structural, civil, and electrical series are coming soon. Subscribe so you don't miss them.